In this section, we find formula for the derivative of logarithmic and exponential function. A review of section 1.5 and 1.6 may prove helpful if you don't remember what we did in that section. In particular, recall that f of x equals e to power x is the exponential function with base e. E is some fixed number which is 2.718, etc. Okay, this is exponential function. Here is the 2.718 blah blah blah. And the inverse of the function e to power x is the natural logarithmic function, which is ln x. So inverse f of x is ln x. More generally, if b is a positive real number which is different than 1, then the exponential function b to power x, okay, more general, f of x is b to power x, and f inverse of x is logarithm base b of x. So the derivative of e to power x can actually in the process of finding the derivative of e to power x, we use the fact that limit when h goes 0, e to power h minus 1 over h equals 1. Okay, by giving some values of the h, you can observe the correctness of this approximation or this limit, but we will not give the proof of this limit to you, but by using this limit I will explain the derivative of the e to power x equals e to power x. So let f of x be e to power x. Okay, so what is the derivative of the f? By using the limit definition, when h goes 0, f of x plus h minus f of x over h. Okay, so this limit is the derivative of the e to power x for the function e to power x. So limit h goes 0, e to power x plus h minus e to power x over h. If you take the e to power x common factor parentheses, maybe step by step, first of all, e to power x times e to power h minus e to power x over h. Now you can take the e to power x common factor parentheses. So we have e to power h minus 1 over h. So as we know, actually as we assumed, maybe we can say that this equals 1. Okay, so this limit goes to 1. E to power x is constant. So as a result, this is e to power x. So derivative of e to power x is e to power x. By using the definition of the limit, definition of derivative, we proved this fact. Okay, and we can show that the derivative of the ln x function. So let f of x be ln x. So derivative of the ln x is limit h goes 0, f of x plus h minus f of x over h. So what is limit when h goes 0? F of x plus h is ln x plus h minus ln x over h. We should calculate this limit. So this implies limit h goes 0 ln x plus h over x over h. You can write this fact in the following form: limit h goes 0 ln actually this is 1 over h, 1 plus h over x. So this is limit h goes 0 ln 1 plus h over x to power 1 over h. Okay, we are familiar to do this part. We are familiar to this part, which is when h goes to infinity, so when h goes to 0, this approach to e. Okay, we have already showed it in the lecture. So limit h goes 0, not h goes 0, this is goes to number e. Okay, so this goes to number e. So this is approach to ln e, and which is equal 1. No, there is some, I had some mistake, because here this is h over x, this is 1 over h, that's correct, but this is what is the formula? Okay, let's recall that formula. So what is this formula? Recall. Limit when, as I remember, in the compound interest formula we have used, when s goes to 0, or when s goes to infinity, m goes to infinity, m times, okay, from the compound interest formula you can recall, okay, when m goes to infinity, 1 plus 1 over m to the power m times m. So this equals e. Or limit when s goes 0, 1 plus s to power 1 over s equals e. In section 3.1 I gave that formula. So now here this is h over x, so it is like to that point where h goes to 0. So we have the h 1 over h over x, but this is 1 over h, so it should be x. So how we can obtain the x? By multiplying and dividing the x in that part. Okay, so let's add the x and we multiply 1 over x. So now this is x to power h, and we have 1 over x. Okay, so now this is 1 over x is not depends on the h, so 1 over x times ln e. Now it goes to e, so the answer is 1 over x. So derivative of the ln x is 1 over x, as you see here. Easily we can generalize the this formula for the other derivative. I mean, for example, if f of x is logarithm base b of x, okay, actually this equals ln x over ln b. So easily you can calculate the derivative of that from here. Derivative of ln x is 1 over x, ln b is constant ln b. So this is 1 over ln b times 1 over x. So derivative of logarithm base b of x is 1 over ln b times 1 over x. Easily you can calculate. But I would like to explain some things about this equality. So how we can obtain this formula? If y equals logarithm base b of x, this implies b to power y equals x. Okay, so that means if you take ln of the both sides, ln b to power y equals ln x. So this implies y times ln b equals ln x. This means y equals ln x over ln b. At the beginning, what is the y? Y is logarithm base b of x. So if you replace y with that one, you will obtain the following result. So logarithm base b of x equals ln x over ln b. In the lecture times, problem solving time, I gave you that formula directly to you. So here we proved this fact, okay? If you would like to calculate the derivative of the b to power x, okay, so for example, if your function is b to power x, what is derivative of this function? You should write the b to power x as the following form, which is e to power ln b to power x. This is always correct, you know. So this is e to power x times ln b. Yes. So let's differentiate. F prime x equals e to power x ln b times derivative of the x ln b side function by the chain rule ln b. If you consider the first case, this equals actually b to power x. So that means derivative of the b to power x is b to power x times ln b. Okay, so we have that formula. Okay, briefly let's write the old formula here. Derivative of e to power x equals itself. Derivative of the b to power x equals b to power x times ln b. Derivative of the ln x is 1 over x. Derivative of the logarithm base b of x 1 over ln b times 1 over x. I have a remark here because commonly you make that mistake. So derivative of d to power x or b to power x not equal x times e to power x minus 1. Okay, this is the remark. Or derivative of b to power x not equal to x times b to power x minus 1. Please be careful.